Welcome and hello. This is a video lesson in EPA SWMM, and in this lesson, I'm going to be discussing simulation options. This lesson will describe the options associated with running an EPA SWMM model. I just opened up my EPA SWMM model. Here it is. You may have a splash screen that also opens up, a welcome screen, if you will, when you open the program. And if you don't, you can go up to Help and then Welcome Screen right here. I'm opening this up because I wanted to use this first sample project, site runoff drainage. So I'll go ahead and load that. And then what I also like to do is just go ahead and save it as a separate project in my own project files. Go ahead and save it right here, and we're ready to rock and roll. All right, so over here in the project browser, this is where we have our options for tidal nodes, options, climatology, hydrology, and so on. The second one down, options, this is where we have our simulation options. So when I click on options, I now have the options listed down below here. General, dates, time steps, dynamic wave, interface files, reporting, and events. So if you go ahead and double click, it will open up a dialog box. And what I'm seeing in this dialog box are separate tabs for those different simulation options. We have general, dates, time steps, dynamic wave, and files. So these 5 tabs here represent the first 5 out of 7 options in this list box right here. So if I happen to double click on time step, then it's going to bring me up the same dialog box, but then just select the time step tab. That way you can just select the different options with the same dialog box open right here. You can also open up that dialog box by selecting on one of your options and then clicking this edit button. That will open up the same dialog box on the tab of the selected option. And then down below here, we have 2 more, reporting and events. These 2 just happen to have their own dialog box. This is for simulation reporting, and then events right here is for the events editor. So in this video, what I'm going to talk about is the first 5 options from general all the way down through interface files, reporting and events. Running the simulation and debugging will be in the next lesson probably. All right, so let's go ahead and get started with general. We're starting here on the general tab, and then we have to specify the process model, the infiltration model, the routing model, and routing options. Those are the 4 categories within this tab. So for process models, these are the different models or parts of the program we want to simulate, such as rainfall runoff, rainfall dependent INI, snowmelt, groundwater, flow routing, and water quality. Notice these are checkboxes, so you can check them on or check them off. You can have multiple processes running in the same simulation. If, for instance, it's grayed out like groundwater here, if there's no aquifer objects in your model, then the groundwater checkbox is disabled, as we're seeing right here. Also, if you happen to want to run a simulation with a process on and then with a process off, so you can compare what sort of results differences occur when the process is on and off, then that's what these checkboxes are good for, just to make it a quick way to toggle on that particular process. All right, next over is the infiltration model, and now we have options for Hortons, green amps, or curve number. Both Horton and green amp have a modified version as well. The Horton method is an empirical method that accounts for the decreasing infiltration rate. And then modified Horton is that as well, but it also accounts for the antecedent soil moisture. The green amp infiltration method is a physical based method that is based on soil properties and suction forces. And then modified green amp is about the green amp as well, except it also allows for non-ponded infiltration. Lastly, curve number. This is again an empirical method that is based on land use and soil type and antecedent moisture conditions. So you can go ahead and read about these infiltration methods some more in the user's manual in section 3.4.2 if you're following along in the PDF version. As far as the infiltration model goes, there's also default values that I want to point out real quick. If you go up to the projects menu and then defaults, and then see if you click on the subcatchment tab at the top, we have the infiltration model. Horton is currently the default that I'm using in this project, but you can go ahead and change that by selecting a different method at the top drop down. And if you happen to select, say, green amp or curve number, then you're going to have to also provide the default parameter values for that particular infiltration method. Lastly, on this topic, you can change the infiltration method of your individual subcatchments just by opening up the properties box And then if you scroll down a little bit, here it is, infiltration data important. You can go ahead and change the individual infiltration method and parameter values for each individual subcatchments in your model. All right, so let's go back to our options. General, that's infiltration model. Next up is the routing model. So we have steady state, kinematic wave, and dynamic wave are our three choices here. And these sort of range from the simplest and least accurate but most stable to the most complicated, most accurate but least stable and probably takes the longest to run. So steady state is the first one. This assumes uniform flow and steady flow within each time step, simply translating inflow hydrographs downstream without delay or change in shape. So that's pretty much the simplest version right there. Kinematic wave is sort of a compromise between the two. This approximates the unsteady flow by assuming that the flow is primarily controlled by gravity and friction, and it neglects inertial forces and pressure forces. And then the last option here is dynamic wave. This is the most accurate method for modeling unsteady flow, but it requires smaller time steps for numerical stability. And a little bit later in this lesson, we'll talk about the dynamic wave tab up here, which is required data if you're going to be using dynamic wave routing model. And then lastly, in this general tab, we have an option to allow for ponding. This allows excess water to collect on top of a node. And if you're going to be using this allow ponding, then within the model, you're also going to want to specify, let's see, here's a junction properties. Yeah, there's this ponding area right here. It's in square feet. So go ahead and specify that ponding area on top of the junction. Okay, let me go back to options and then general tab. The last one here is the minimum conduit slope. This is the minimum conduit value allowed for a conduit's slope. All right, let's carry on to our next tab here. This is the dates tab under simulation options. This tab sets the starting and ending date times of the simulation. So we have start analysis and end analysis, and we also have a start reporting on. So right now, by default, it looks like it's going to start on the first day of 1998, and it's going to end on the first day of 1998, 6 hours later. So it starts at 0, hours, it goes till 600 hours, 6 o'clock a.m., and it's going to start the reporting at the beginning of the simulation. So most always, you'd probably want the reporting to occur and start at the beginning of the simulation, but if you don't, for whatever reason, you can actually change the date time that the reporting begins. We can also start and end the sweeping. So if your model happens to have street sweeping involved, then you can go ahead and select the dates that starts and ends. And then the antecedent dry days down here, this is the number of days that no rainfall occurs prior to the start of the simulation. This value is used to compute an initial buildup of pollutant load on the surface of the subcatchments. The next tab over is time steps. So this tab sets the length of time steps used for runoff, routing, and reporting. So for instance, we have the reporting time step here. By default, it's going to occur once every minute. And then below that, we have the dry weather and wet weather runoff time step. Wet weather is set to 1 minute for this model, and then dry weather is set to 1 hour for this model. You can go ahead and change these numbers by clicking on a cell and then clicking on the arrow up or arrow down buttons. You can also just use the keyboard by go ahead and selecting a number and then typing in the number. The difference between dry weather and wet weather is, well, I'll define wet weather first. Wet weather is basically during all periods where there's rainfall, precipitation, ponding, infiltration, or evaporation occurring within the model. And then that means the dry weather is any time during the model simulation where none of those previously mentioned processes are taking place. All right, down below this, we have the control rule step. This is the time step or how often that the control rules are checked within the model simulation. The time step used for evaluating control rules, the default value is 0. And if it's left at 0, then the control rules will be evaluated every time step, which in this case is every 15 seconds. 15 seconds is currently what is set for the routing step. This is the simulation time step. You may need to set this to smaller numbers if you happen to be using the dynamic wave routing model. This is one of those fields where there's sort of a trade-off between accuracy and stability versus the duration it takes to actually run the model. So for instance, if your model is going unstable, you may need to decrease the routing time step. And if your model is taking forever to run, but it's already stable and accurate, you may be able to increase the routing time step, and that will improve the runtime. But if you increase the routing time step too much, then you may experience inaccuracy in the model or instability in your model run. Below that, we have a checkbox here to skip steady flow periods. So if you check that on, what will happen is the simulation will just skip over any time periods that satisfy the criteria down below. So for instance, we have system flow tolerance 5% and lateral flow tolerance 5%. System flow tolerance refers to the total system inflow versus the total system outflow. So if that difference is less than 5%, you can skip that time period. Lateral flow tolerance, this refers to the flows in all the laterals between consecutive time steps. If that change is less than 5%, again, skip it. All right, well, that's it for the time step tab. Next up is the dynamic wave tab. These options here are only used by the EPA SWMM program if you happen to select dynamic wave for your routing model here on the general tab. So let's check them out. Dynamic wave. The options here for the inertial terms are keep, dampen, and ignore. So if you select ignore, that basically means that the inertial terms will be ignored. If you keep them, then that's going to consider the inertial term. Or if you select dampen, which is the default here, that will reduce the term as the flow approaches critical. All right, the next one down is normal flow criterion. That's based on slope, slope and Froude number, or none. So slope was the default here, or at least that's what it was for this model, and that's the energy grade line slope. All right, the force main equation. This is either Hazen-Williams or Darcy-Weisbach. These are your options for computing the friction in a force main when you have a fully flowing conduit, which would experience friction, oftentimes on the downstream side of a pump, force main. And then surcharge method is right here. The options are Xtran and slot. The user's manual also describes these options. After that, we have a checkbox here for use variable time steps adjusted by. So if you don't want to adjust the time step, then you can just uncheck this. But if you want EPA SWMM to be able to adjust the time step during the simulation, go ahead and check that on. And then the time step will toggle between the original 15 seconds, but it could also change down to as low as the next value you type in here, which is the minimum variable time step in seconds. The time step will be automatically adjusted between the minimum variable time step and the maximum time step, which I mentioned right here is 15 seconds at the moment. It's used to maintain model stability based on the current condition. After that, we have a time step for conduit lengthening. This is in seconds. If it's left to 0, that means there's no artificial lengthening of the conduits. But if you go ahead and include a number here, this is to further decrease the current number in the model with artificial lengthening the conduits, which is described more in the user's manual in section 9.2. So of course, if your distance to cover over the length of the conduit increases, that will decrease the current number and improve the model stability. All right, after that, we have minimum nodal surface in square feet. This happens to be the amount of square feet in a 4-foot diameter shape, like a 4-foot manhole. Go ahead and change that if you want. Head convergence tolerance and maximum trials per time step. These are the two values that are associated with the convergence criteria. When the simulation is running, it's going to continuously check that this head convergence tolerance is met or it's not met. If it's not met, it will just run another iteration. And it'll continue running iterations until this particular convergence criteria is met or until the maximum number of trials in that time step is met. So that's how that works. If your model is not converging, then you may need to increase the tolerance value here or increase the number of trials here used in a current time step. All right, and the last one is the number of parallel threads. This is associated with your computer and how many threads it's going to be using. The default is 1, but you can change that just by using the arrows here. And then if you click on the little info button, it tells you how many your computer has. Mine happens to have 10 physical cores and 12 logical processors. Okay. If you happen to be running a large model and it's taking a long time to run, you may want to consider increasing this number from 1 up to something more. And we're finally on to the last tab of our simulation options. That's the Files tab right here. This specifies which interface files will be used or saved during the simulation. So as you see right now, I don't have any files listed, but I can add files, edit the files, and delete the files. So if I add the files, I get this dialog box that allows me to specify the file type. And our options here are rainfall, runoff, RDII, hot start, inflows, and outflows. Once I select a file type, I then have to specify if I'm going to save the file or use the file, and then I need to navigate to that specific file and where it's saved on my computer. So once I click OK, it'll be listed in the list box. I can select that to either edit or delete, or I can add a new file. I'm probably going to do an example of this because right now I'm just kind of glossing over the details, but this is important when including files in your simulation. All right, well, that's it for this lesson. What we talked about were simulation options in EPA SWMM, including general, dates, time steps, dynamic wave, and files.